So let's look. Let's go ahead and label the side of the triangles with the O for the opposite, A and H for hypotenuse. How do I know? First step, every time you see the right angle, if you draw an arrow from it, that is always going to be your hypotenuse. Next one. Hypotenuse. Right angle. Hypotenuse. Okay? Now, some students, some of you may have learned this, but you may have already forgotten which side is my opposite and which side is my adjacent. Okay? What side is my opposite and what side is my adjacent? Okay? So, here's how I do it. We're going to start using not just the 90-degree angle to know where our hypotenuse is. We're going to start talking about other angles. One of those other sides we're going to talk about. So, for an example, they indicated this is the angle that we're talking about right here for letter C. And the leg that's in between the right angle as well as my other theta, and that's what an angle is called, a theta, that is going to be my adjacent leg. And that's how I know it. You may have learned it a different way. Again, there's more than one way to do things. That's okay. One more time. If this is my theta and this is my right angle, then this leg has to be my A. Here we go. Here's my theta. Here's my right angle. Then this leg has to be my A. Then whatever is left over is my O for my opposite. Okay? So that's how I learned it. You may have learned it a different way. That's okay. Now, there will be some triangles that they don't actually give you the little theta right there, that little thing. That's okay, because within the word problem, you're going to read it. You're going to draw out the triangle yourself, and you're going to figure out where the theta is. You draw that little mark in, and then you're going to know which way the H, the A, and the O is, okay? So I'm going to leave those three over here for you to practice. If you have questions, class time, you need to ask me, okay? But those three are there for you to practice. Now, let's go ahead to step 2. We're baby stepping. Now we're about to do some crawling, and then we're going to do some walking. Okay, and then after that, we're going to be doing running. Okay, so that was crawling. Let's baby step this. Let's go ahead and get your calculator out because you need to practice this for sine, cosine, and tan. Okay, so let's go ahead and let's have some of you, you know what? Actually, I'm not going to do this on the video. I'm only going to wait till we get to class because this is so important. If you don't do this right, then screw it, forget it. Then everything else on your equations are wrong because there's a certain step that most students forget and don't do it at all, and they get this part wrong, and you need to know how to do this part. Okay? So I'm not doing that part now. I will do that part in the video. I'm sorry, in our lessons when we have each other. Not only am I not going to do it right now, let me go ahead and mark it. So when we meet again in class, I know that I need to go over this section with you because I need to make sure that everyone knows how to do this, how to put this in the calculator the correct way. You have to be able to do this first before you go over here. Okay, and I want to see if you're getting the answers right or wrong. Let's go ahead and let's write down our equations, talk about setting them up and all of that good business before we go any further. Okay, so there's a problem. Sometimes you will not be given the A and the B leg, or they won't give you the B and the C leg for your right angle triangles. Sometimes they will only give you one leg and this little thing right here that we call the theta, okay? But you can still use that information to find the other two legs if needed, okay? So we use what we call SOHCAHTOA. SOHCAHTOA, all right? Now the SOHCAHTOA here has an equation. Hopefully, you remember it. I don't know if you do or not, but I'm about to write down the equations for y'all. Okay? Here they are. We're going to do this one as tan. This is going to be my cosine. And this is going to be my sine equation. Okay? So let's go ahead and fill this in. My tan. Tangent of the theta equals the opposite over the adjacent. Right? SOHCAHTOA. T equals O divided by A. Let's go to the K part. The cosine of theta equals the adjacent over the hypotenuse. What is that? That is going to be my cosine equals my adjacent divided by my hypotenuse. Do you see it? My T, my K. Let's go ahead and do my SO. The sine of the theta equals my opposite over my hypotenuse. And this, and this, if you've seen so far and paid attention when I'm like writing numbers, you've seen me do zeros, and I do zeros and I do a little slash sideways. But when the slash is completely horizontal, those are what we call right here, this angle, we call those thetas. Okay, so this symbol is called a theta. One more time, that symbol is called a theta. Now let's go ahead and get ready and turn the page. For our next part. I'm sorry, I'm almost done. So THETA, theta. Okay? Let's turn the page. Now we're going to practice this a little bit. Okay? Not a lot, but just a little bit, because I really prefer for us to practice it in class together. So I'm just going to go over a little bit, but we're really going to go over it in class. That's where we'll go over it. So A, B, C, D. Alrighty. So here it says, let's go ahead and use our SOHCAHTOA equation to go ahead and solve for these. How do I know I'm going to use SOHCAHTOA? Well, I see that I have a right angle. Your step number one is to label the legs. I know some of us feel like you can just go ahead and just do this on your own. That's fine. Some of us need to go back to our steps, okay? So step number one is going to be the A, the H, and the O on the legs. Label them. So in this case, what do I have? I have my right angle. If I go across from my right angle, I'm always going to have my hypotenuse. They gave me my theta right here of 35 degrees. So between my theta and my right angle, this leg is always going to be my adjacent. And what's left over is my opposite. So step one is to label the A, the H, and the O on the legs. Okay? Step number two, we have to figure out what we have. What do I have? Well, I have the H leg, and that's it. And I have a theta. So with an H leg and a theta, what am I going to do? Well, let me go back another step. Number 2 is going to be what you are given and looking for. For those of us who didn't have the best geometry in the past, here I'm just coming up with little simple steps on how I do my math. What was I given? I was given my H leg. What am I looking for? I'm looking for my O leg. Which equation over here is going to indicate or utilize the H and the O? When I look, all I see is this right here. The sine of the opposite over the hypotenuse. Opposite and hypotenuse. Okay? So let's go ahead and do that. The formula is going to be the sine of the theta equals, what's it say? O over H. Now let's go ahead and fill it in. The sine. Now I'm not going to write that theta anymore. I know the theta. The theta is 35 degrees. Of 35 degrees, okay, equals, what is my opposite? My opposite is letter B. You, in math class before, if you've done this, you might put letter B. That's up to you. Me, personally, I like to just put what I'm looking for. What am I looking? I'm looking for the opposite leg. But you're more than welcome to put the letter B, okay? Over hypotenuse. What is my hypotenuse? 16 centimeters. 16. Okay? We have to get O by itself because that's what I'm looking for. So step number 1 with your algebra skills, right, is you're going to go ahead and multiply this side by 16 to cancel out. Multiply this side by 16 and get your answer. Okay? But again, I'm not sure on your math here, so I'm not going to answer it. We're going to come back together and we will answer this for sure in class, making sure that we're all on the same page. So I'm going to go ahead and leave this here. I'm going to set them up though, and I'm not going to go any further with any more answering though. Okay, let's look at the next one. The next one's over here. It says we've got the letter J leg, and they gave us this and this information. What is my step number 1? To label the A, the H, and the O. Let's go ahead and do that. Here is my right angle. Here is my theta. Draw the line. Opposite is going to equal my hypotenuse. The right angle and the theta is always where the adjacent is. What's left over is the opposite. So I have it labeled. Great. Next question. What are they giving you and what are you looking for? So I'm going to go ahead with my highlighter, and normally this is where I use my highlighter for this unit a lot with this. I'm given this leg H, hypotenuse, and they want me to look for this side, which is the O. So again, what am I looking for? The O and the H. Come to my SOHCAHTOA. The O and the H is only here in the SO part. So my formula is going to be the sine of the theta equals O over H. Or the sine, we don't write theta symbol anymore. We're going to use our actual degree, 60 degrees, equals my O. I don't have my O, I'm looking for it, over my H, which is 8 kilometers. Okay? This I will be calling in person out in class because I need you to do the math for me. I need to see your math, hear your math, I guess. Multiply this side by 8 to cancel. Multiply this side by 8. Right? We're going to solve, and we're over here we found out that O equal blank. O equal blank. This was kilometers. This was centimeters. Okay, we are going to figure this out in class together. There we go. Let's keep going because I do want to set you up. If you feel like you can do this on your own and you know how to, great, go for it. But I'm afraid some of us are not going to put it in the correct way. Let's go ahead and let's keep going. Next one, letter C. What do? I label the A, the H, the O. first find the right angle that they give me, draw an arrow to the opposite side of it. When I draw that arrow to the opposite side, that is going to be my H. What do I do for the next one? I find out where my theta is in my right angle, and this leg is always going to be your A. Left over is your O. I use my highlighter, okay, because believe me, we're going to get to more. You're going to need this highlighter. It's so helpful. I'm going to highlight what I'm given, which is my H, and I'm going to highlight what I'm looking for. This leg, they called it N. That's my H and my O. What equation uses H and O from the SOHCAHTOA? The SO. So the sine of the theta is O over H. Or the sine, we're not going to use theta, we're going to use the degrees of 23 degrees equals O, which again is my unknown, over 38 centimeters. Multiply this side by 38. That cancels. Multiply this side by 38. O equals blank centimeters. Next part. Practice it again. Here's my right angle. What do? I draw a line from the opposite side of it, which is my hypotenuse. I find out where my theta is, and that leg that has the right angle and the theta together is always going to be my A. The leftover one is my O. Step number 2, highlighter. What do? I highlight what they give me and what I'm looking for. They gave me this leg, and I'm looking for this leg. What is that? That's the A and the H. So let's come to my SOHCAHTOA. Who has A and H in it? It's not the SO. Ka, A and H. It's the ka part. So my cosine of the theta equals, what does it say? A divided by H. Or, we'll fill it in. The cosine of 48 degrees equals A. I have the A of 10 over H. I'm looking for the hypotenuse leg. Okay? Believe it or not, I know this sounds a little crazy, but this is another reason why I love the triangle, because this can be put into the triangle. Cosine equals A over H. You always cover up what the equal part is. A goes on top of the division. H is at the bottom. The other side is the cosine of the theta. What am I looking for? I'm looking for H. So I'm going to look for H. I'm going to circle it. H, cover that up, equals the adjacent leg over the cosine of the theta. Bam. I got your algebra already knocked out of the way, so you don't have to make any algebraic mistakes. Now I'm telling you, as the school year goes along, you're going to love my little tricks here and there. Okay? It's amazing, the stuff that's like I know in my head. It's so awesome. Now I'm going to go back here. Since I just got through that equation that has the triangle in it, I want to go ahead and show you this one. They all can be put into the triangle. The tan of the theta is the opposite over the adjacent. Opposite has to go in first. The adjacent can go anywhere at the bottom. And then the tan of the theta. Right? The cosine adjacent over the hypotenuse and cosine of the theta. This one. The sine equals the opposite over the hypotenuse, and then we put sine of theta. Now, did your algebra teacher show you this in algebra class, or geometry class, I meant to say? That's making your life livable. I love math. Okay, let's keep going, because we're not done. The next question here, I'm trying to find where it is over here. Talks about an archaeologist. Here it is. So an archaeologist climbs the Great Pyramid of Giza. If the pyramid's height is 140 meters with the width of 230 meters, what is the magnitude and direction of the archaeologist's displacement while climbing from the bottom to the top? Okay, this is a good practice problem for us to do together. First step, what do? Well, we have this big word problem and we're going to have to figure it out. But for me, I like to do drawings. I need to see it. I'm a visual person. So let me draw it out. Here's the Pyramid of Giza. I have an archaeologist who wants to climb to the top. Perfect. He wants to go that direction. He wants to find out his displacement, which is this vector arrow, but he also wants to know the direction. When they say displacement, displacement means two things. It means, well, displacement is a vector quantity, right? So when they say the word displacement, they mean magnitude, because it's a vector, and direction. Remember, going back, everything in physics is vectors or scalars. Okay? So there might be times where they may not tell you magnitude and direction. Sometimes they might leave that out and they want to know what is the archaeologist's displacement, and they're only going to use that word. When they use only that word, it still means magnitude and direction. You have to find both. Now, go and think about somebody who is an airplane pilot or is a boat, a captain on a boat. And these people who are airplane pilots or boat captains, they use degrees to find their direction. So they're going to go ahead and turn the boat 58 degrees west. Or the airplane pilot is going to turn the airplane or fly 16 degrees northwest. Okay? So they're going to use those degrees to figure out their direction. So when they say direction, they mean degrees. And I'm going to put right here an arrow, degrees. And what is our degrees? Look, we saw our degrees over here. And what do we call those degrees? We call it the theta. So you are looking, or you're going to give an answer of a theta, which is a degrees, and magnitude, which is a number value. Okay. Now, there's a couple of things that were given to us. They told us the height of this pyramid, which is 140 meters. They also told us the width of the pyramid from here to here is 230 meters. Now that I drew it out, they can't trick me anymore because I definitely know that this is a right angle. I see that. But remember how they tried to trick us earlier? We're only looking at this part of the angle, or this part of the triangle. So I've got to get this number and divide it by 2, which now is 115 meters on this side, because that's all I'm looking that part of the triangle. So do you see that they gave me this leg and they gave me this leg? So I got 2 legs. I need to find this leg. Okay, well, we can do that. How would we find that leg if I've got this leg and this leg? Hopefully your brain is already going to Pythagorean theorem. You're absolutely correct. But how do you find direction? Or how do you find the theta? Well, we just did those equations. The SOHCAHTOA are the equations that you use to find the theta. Okay? Pythagorean theorem you use if they give you 2 legs and you're looking for the other legs, you use Pythagorean. If they give you 1 leg and the theta, then you use SOHCAHTOA to find the other leg. If they give you 2 legs and they want you to find the theta, then you're going to use SOHCAHTOA to find the theta. Now, the most important part now, before we go any further, is where the heck is the theta? I know this is my right angle, but where's my theta? Is my theta over here or is my theta over here? Well, your theta is going to be where you start at and it's going to be the bottom of the arrow. Do you see that this is my vector arrow? This is the tail end of the arrow. This is the head of the arrow. The tail end is going to be where your theta is. Okay? Let's go back just in case so you can see it. Here's my airplane. Here's my tail end of my arrow. This right here would be my theta. So now, look over here. Here's a right angle, but here's my arrow. This is the tail end. This would be my theta. Let's look at this one. Again, here's a right angle. Here's my tail end of my arrow. This is my theta. You have to be able to read the word problems and figure out where your theta is. Okay, so here I'd look, and how do I figure it out? I figured out by doing drawings. This is my theta. So I'm looking for this is my unknown, and this leg is my unknown. Okay, so let's go ahead and let's do this. This is, I'm telling you, I'm hoping you watch this before we actually have class, but I will go over this in class. Okay, first step, well, I'm going to go ahead and let's get the SOHCAHTOA out of the way. So it's a two-step problem. I'm going to get two parts, two answers. Part number one, for me, I just like to get SOHCAHTOA and knock it out of the way. Going back to my highlighter, what do I have and what am I given? Well, I forgot a step. Here's my right angle. Draw my arrow. This is my hypotenuse. I figured out that this is my theta, so this leg is my adjacent, and this leg is my opposite. Okay? What do I have and what am I looking for? Well, I definitely know that I'm looking for the hypotenuse, so I'm just going to go ahead and highlight this side. Hypotenuse. Now, I'm going to go ahead and just pick one. Either it's going to be that one, or it's going to be this one. So when I'm looking at it, first thing is I'm looking for this side, but now look, I've got the opportunity myself to go ahead and pick which one I want to use. Okay? So I can solve for this theta. Let's go ahead and use, oh, I'm so sorry. Scratch all of that. I was thinking about Pythagorean. We can do that too. We can do that first. So forgive me. For Pythagorean theorem, what do I have? I have, this is my C, because this is my hypotenuse. I have my A and my B leg. So I'm so sorry. Let's do that real quick. A squared plus B squared equals C squared. Okay? Or 115 squared plus 140 squared equals C squared. Get those two numbers, add them up, square root it at the end, don't forget, and figure out what your C is. And your C is going to be in meters. Now let's go back to the theta. Two-step problem. Now I need to know about my theta. So what am I going to do here? Well, I'm not worried about the leg anymore. I actually solved it. Whatever this is right here, it's going to go in here. So forget about the leg. I'm looking at the theta. And when I look at the theta, what am I given? I'm given the A and the O. The A and the O. Right? Before I found this one, I have the A and the O. And if we don't remember, then let's go ahead and write it down. So, SOHCAHTOA. Who has the A and the O in it? The tan. So we're going to say the tan of the theta equals O over A. Do I know the theta? No, I don't know it. I'm looking for it. So we're going to leave it as the tan of the theta, because I don't know it, equals, what is my O? 140 over my A, 115. Okay? The tan of the theta equals, I need that number from you. And again, I'm going to go over this with you in class, but I'm not finishing it anymore because I need your participation in class, because this is your grade. I have the answers. I know the answers. I know how to plug it into the calculator. Do you know how to? Okay? And so I need to know that you know. For those of us who don't speak up in class, but yet you're sending me emails saying you don't know, well, you know what? You need to speak up in class. You need to. This is your grade, your education. So step up for your grade. Next part, we've got practice problems. Okay? Tons of practice problems. Because the only way we're going to get better is if we practice them over and over and over again. So let's look at a couple of them here, and then we can practice some as well in class. First one, a hummingbird. A hummingbird flies 1.2 meters along a straight path in the sky. Upon spotting a flower below, the hummingbird drops directly downward 1.4 meters to hover in front of the flower. What is the hummingbird's total displacement? In parentheses, this includes angle and magnitude. I am not going to continue to put parentheses and give you that information. Quiz and test day, that's up to you to solve and figure out. You need to know that the word displacement is two numbers and give me both numbers. Okay? So on here, let's go ahead and solve this problem. What do? Step number 1. I'm going to draw it out. I've got to figure this out. So I'm going to get my hummingbird. And I just got the long little beak thing. Needle nose kind of thing it's got. Here's a little feathers. So there's my hummingbird. This is some good drawing. You need to zoom in for this. And how is it drawn? It's flying. It's flying along a straight path in the sky. So I know it's flying horizontally. I don't have any information other than this is a positive number, and it doesn't tell me anything other than that. So in my eyes, after reading this, I'm reading it as it's going this direction, 1.2 meters. Yes, this is a positive number, but they use the word downward. 1.4 meters. There is a flower that the hummingbird sees. What direction is this hummingbird gonna go? What is the resultant displacement? Overall, one arrow is all you're gonna get to draw, and it has to be straight. The hummingbird's going to go in this direction. Do you not see the right angle? Yes, you do. There it is. What did I tell you when it comes to vectors, when it comes to displacement, or the theta? The theta is always located on the tail end of your vector.